Hello friends, welcome to another tutorial in analog electronics. In this tutorial we'll start discussing about the differential amplifier. If this is something that interests you, then please keep watching. We'll talk about various configurations in which differential amplifier is made, and we'll talk about the schematic diagram, and the first video consists of the DC analysis of the differential amplifier. So let us begin. By the definition of a differential amplifier, it's a type of electronic amplifier that amplifies the difference between the two input voltages. So this is going to be the schematic diagram of a differential amplifier. We have two inputs. This input is known as inverting input and this input is known as non-inverting input. Two inputs are given, V1 and V2, and output V0 is given by A into V1 minus V2. So the output is basically the difference between the two input voltages, and of course multiplied by the amplification factor. Then we have the feedback resistance here, which we'll talk about later when we talk about various applications of the differential amplifier. But in a nutshell, this is the schematic diagram of a differential amplifier that you must know. Otherwise, the electronic diagram of a differential amplifier consists of two identical transistors arranged in such a way that we have two inputs, V in 1, V in 2, and the output V0 is taken as the difference between the two voltages, one from the transistor 1 and the other one from the transistor 2. V1 minus V2 is what we get as the output. This is the circuit diagram for a differential amplifier, and based upon this circuit diagram, various permutations are possible. For example, we could have two inputs and the difference of the output, which is known as the balanced output, and we could just give one input and keep the other input grounded and take a balanced output. Then we could give two inputs and take output from just one terminal and do not use this terminal. So depending upon all that, we have four different configurations. So depending upon inputs and outputs, there are four configurations possible. One is the dual input balanced output, which is this one, and the dual input unbalanced output will have just one output gone, so we'll take output from just one terminal. Single input balanced output will have one input gone, but output will have two terminals, both from Q1 and Q2, and single input unbalanced output will be just single input and single output. But in this video we'll talk about dual input balanced output amplifiers DC analysis. So when we talk about DC analysis, what we are concerned about is we are concerned about finding IC and VCE. So how do we find IC and VCE? We can start our DC analysis by shorting this one. All the AC sources are shorted and all the capacitors, if there are any, are removed. So applying KVL here in this loop, what we get here is, so I can remove this V in and I'll apply KVL here. But while applying KVL, I know that the current in this RB resistor, which is input resistance, also is IB, and in this RE resistor we have twice of IE flowing through it. So what we have here is, let's start our loop equation generation. We have IBRB, the first term, the first voltage drop will get here, Then we have VBE, which is the voltage at base emitter junction. Then we have the voltage drop at RE, which is twice of IE into RE, and that will be equivalent to VEE. So going from positive to negative, positive to negative, positive to negative, all these three things come on the right hand side, and this is negative to positive, so we get this thing on the left hand side. Next we use the approximation that we know that IC is equivalent to beta times IB, and IC is approximately equivalent to IE, so IB will become IE upon beta. And so I substitute this IE here. So IB is replaced as IE upon beta into R input or RB. I can say it as RB, VBE, IE, RE. So taking IE common and taking this VBE on the other side, I get IE to be equivalent to VEE minus VBE upon Rn upon beta plus 2RE. Now we know that beta is very, very larger than 1, so this quantity can be ignored, and finally the value of IE, which is also equivalent to IC, comes out to be VEE minus VBE upon 2RE. So that's half the portion done. So in DC analysis, the IC is VEE minus VBE upon 2RE. Then we need to find VCE. In order to find VCE, let's assume the voltage here at VC, and VCE is VC minus VE, and we know that VCC in this outer loop going from VCC, I get VCC plus IC RC, some drop here, and then VC. The voltage VC is from this point to this point. So VCE becomes VCC minus ICRC minus VE. So this is the equation for VCE. Again, very, very simple. The DC analysis is very simple, but the main idea is to appreciate the fact that the output here is the difference between the two input voltages, and as far as the DC analysis is concerned, we see that this depends upon this common RE, and these two transistors are matched transistors, so VBE is also considered to be the same for both the transistors. So that is all that I wanted to discuss in the first tutorial for the differential amplifier. In the next tutorial we'll talk about the AC analysis of differential amplifier. I hope this video helped, and if you liked the video, give it a thumbs up. Consider subscribing to the channel, share this video amongst your friends, and I'll see you around in the next video. Till then, take very good care of your health and stay happy. Bye.